Hey, you drinking my coffee? Hey, I'm talking to you. Oh, shop rat. What do you think you're doing? That's my coffee. Oh yeah, I know. You weren't doing anything, right? Hey, my name is Dan. Welcome to my shop, and today we are continuing to scratch build this Ryan's Rebel. Modeling can sometimes be a one step forward, two steps back, or sometimes it's a two steps forward, one step back. Today we're going to do a two steps forward, one step back. I'm going to make a lineup change on the engine that I selected for this project. This was the original engine that I had, which is a US 41 engine, also known as a Quadra 41 or 42. I don't know where they came up with it. I think it's also a Quadra 35. But I don't know, I just have my doubts about this setup, and I decided, you know what, I'm gonna go ahead and make a bit of an upgrade to this. And I ordered a DLE 30 engine, which is probably something that is it's more the right size for this project. In fact, the original designer built his around a Ryobi 31, which is right about the same size. But I went out a couple weeks ago and I got to fly my buddy Mark's Ryan's Rebel that he completed. It's got a Homelight 30 on it as well. And the thing that I noticed was it had plenty of power. It had more than enough power with the 30cc engine instead of going to say a 42. So I went ahead and did it. I went ahead and bought the DLE 30, which is a nice lightweight engine. This is an engine that was made specifically for modeling. It wasn't like this one here, which was, you know, they come off the assembly line and some of them go into weed whackers, some of them go into chainsaws, things like that, leaf blowers. And some of them go to another factory where they will try to cut them up a little bit and make them into an airplane engine. And that's fine, but weight is a consideration when you do that. Now you can see the 42, 41, 42, or whatever it is, US 41, also has the old flywheel on it. This is an original piece. It's inside of the, it goes on, like if it's inside of a cowl of, say, like a leaf blower or something like that. This thing with all the fins on it helps circulate air inside that enclosed cowl to keep it from overheating. And it's just part of the design of it. Well, on a model airplane, we don't need this big old heavy thing, and this is heavy. I mean, it's a big piece of aluminum, but it's got these big heavy magnets on there. And then the other part that's heavy is this here. That's a magneto. A magneto is kind of a big old chunk. It's got heavy metal. I mean, these are heavy metal leaves all stuck together on the side there, and it adds a significant weight to it. So by comparison, this one here had that all removed. When this was built, it was made specifically to become a model airplane engine. So up in the front here, it's got the solid state ignition, and I'll do another shot here so you can see this, that there is a magnet built into the flywheel on here, and it picks up, there's a little sending unit right here. And when the magnet goes by, it tells the spark plug to fire. Very compact, whereas this one here is pretty big. So this is a much better solution, much lighter weight. The only downside to it really, other than it costs a little bit more than this other engine cost me, it's got an electronic ignition module. So that's gonna add a little bit of weight and complexity to it. Not bad. And then the other thing is it's gonna need its own battery. So I've got a 1100 milliamp 6.6 lithium battery. That'll be powering it from the inside, supplying the energy to this too. So the downside is it takes away some of the simpleness of this airplane, because in order to run it now, I've got to maintain two batteries, the one that's maintaining the radio as well as the one for the ignition. But we'll get around that. Now, how does this affect what we've already done? Well, remember those T-nuts that I put in on the last project? Right there. Well, this does not match. The whole pattern is completely different. So we're going to have to remove these. And okay, I think I alluded to this last time. T-nuts are not exactly my favorite mounting system when it comes to putting them into the firewall. The reason why is because they are very very sensitive to accidentally being pushed back in down the road, and especially after being subject to vibration for a while. So I'm going to show you, this is why I don't like them, and I'm going to show you because it's going to be really easy to remove this. So in order to remove this, what I'll do is I'll just go ahead and back this thing out just a wee bit. In fact, I'll take it most of the way out, get all that stuff out of the way. Yep, getting her done. Okay. Sure. Now keep in mind that, like in that last episode, I glued these T-nuts into place. I put a little bit of my favorite glue, the Gorilla Glue, to the back of them to help hold them in. So that couldn't have took any longer than I did there. Okay, so let's stage this like this. Pretend like you had to pull the engine off to do some kind of maintenance on it or something like that, and you go to put this back in here, and you put that in there, and what happens is after this engine's been running for a while, it will kind of vibrate that nut that's back in the back end of that firewall quite a bit, probably loosen it up. So a lot of times, look at this, there, it's out. And so when you're resetting the nut, sometimes it will give you some problems. But see, that's how easy that came out. That was the glued nut to the back of the firewall. So luckily the glue comes right off of it, and we'll be able to recycle and use that one again if we need to. But I've got to do that to the other two here to get them backed out, and then we'll move on to the next phase. Okay, now the next step that we're going to do to clean up this mess that we just made is we're going to take and we're going to drill these holes out, and I'm going to stick a bit of a dowel into it to fill it. So we'll use this is a 5/16 dowel that I just had laying around in my scrap pile. So what we'll do is we'll go ahead and use the drill to drill these holes out to 5/16, and then we'll glue them into position. Stuff in the way over here. Okay. All right, so there we've got those out and drilled all the way through. And next thing we'll do is I'll go ahead and put that in there. We want to make sure, I'll feel through the back here to make sure that that dowel passes all the way to the back of the firewall. One down, 3 to go. messy workbench. And the last one. Okay, all nice and sawed off and flush. What we'll do right now is we'll take a little bit of thin CA and run it around the edges of that so those dowels will not come out. Now I got a comment, a question in the comments of one of the videos that I did, talking about the markings that I put on the firewall when I'm working on a model. And let me just walk you through this really quick. Since this is a square firewall, pretty much square, what I want to do is I want to know where the center of this firewall is. And so what I do is I will put a corner to corner mark, so to make one strike that way. Then the next line will go this way, this corner to this corner, and that'll give me the X in the middle. So with that, I can pretty much tell where the middle of it is. So then I put a couple other lines I will take, and I'll use a square on the side to run a horizontal line across there. So that'll give me that one, and then the vertical line. So now when I go to add the new engine, I'll show you what this is going to look like here. See if I can do this without. Okay, so when I go to add this new engine, I know approximately where the center is. I need to back this out just a wee bit. So knowing where this is, an itch there, I can look and see from where these lines sit, where all the pedestals are going to go, to make sure that I've got them fairly close to center. So in other words, I know where the center is. The center is going to have to be where the center of that, or the center is going to have to be right about where that carburetor is, right in the middle. So that's going to have to be right over the center point. Then I'll use the legs to kind of make sure that they're all about the same distance away from all those diagonal lines. So you can see like the one that's on the front there is actually way to the outside of there. Well, so what I can do is I can slide the other one up so that it's in approximately the same position. You can almost see it behind the engine, but it's in the same position there. Then I'll look down at the bottom two and see that they are also right about on the same spots on those diagonal lines that are down there. And if everything is like that, then the engine should be, you know, fairly centered, as well as centered this way too. And that's what I use. I just do that as reference lines. Here's some other markings on here that, okay, so you can see right there it says F1. So F1, that's former number 1, so that's the firewall. So that was me just marking the parts after I got done cutting them. And then here's an up and a down. Once I glued this onto the firewall, I put down and up just so I had a reference, because you know, when you're building a fuselage and it doesn't look like an airplane yet, you want to make sure that you got it straight so that when you go to put on other parts, you're remembering which is up and down on this thing. So that's what those notes were for. But pretty much all of these lines that I put on here are just to help center the mounting of the engine onto the surface. So when it comes time now, I'll be able to kind of reference to where it sits amongst all these lines, and it should work fine. Once I get all those marks plotted, then we'll drill holes again. And this one's going to be a little bit different. This one's not going to use T-nuts on it. The mounting system for the DLEs is going to be, we drill a hole that will pass this bolt here through. So what's going to happen is this bolt is going to come back through the firewall from the back side and then tightened up. It's also going to have, I kind of messed that up. It's also going to have this washer that it will be pushing against the back of the firewall with to hold it in there. So that'll be the primary piece holding this onto the airplane. And that's great. That'll work fine. I'll just have to reach the nut driver back through here to get to those when I go to install it. It'll work fine. It's just different than what we had before with the T-nuts. One thing that I'm probably going to do is I'll put down a little bit of the Loctite on here. I'll use like maybe a little bit of blue or something, just so that it has a good solid grip through there and make it through the vibration that it's going to go through on the back. So anyways, that's the lineup change that we got coming, and I'm pretty excited about it. I think that this will be a much better engine for it. And just for the numbers sakes of it all, by going to this, going from this engine to this engine, I did the math on it. Looks like we'll be saving about a pound and 2 ounces off of the front end. That'll make the plane lighter, and it'll make it much more, it'll make it so the loading on it is going to be a lot better off. So that's the lineup change for this time around. And like I said, sometimes modeling can be a 2 steps forward, 1 step back, and that's exactly what this is. But sometimes as you're building a plane, you think, wow, man, I could have got a better part for it, or maybe I should have got a different retract for it, or maybe I should have got a different size gas tank or something. The nice part is when you're scratch building, a lot of times you have the ability to back up and rebuild a section and start over again. When you have an ARF, it's already built, so you don't have that much flexibility. So I was able to back up, put the dowels in there. We'll go ahead and reset the place where the pillars, these are called standoffs, and where they're going to sit up against there. We'll be able to fix all that stuff and get it back in action. It's going to be awesome. I can't wait to run this engine, actually. I put a video in the new, oh, that's the thing. We are now past 1,000 subscribers. Oh, it's so awesome. Thank you so much for subscribing. And if you haven't subscribed so far, please do and join our community. I got the community page now, and I stuck my first post on there. It was me and my buddy Mark. We were running up a brand new engine on his huge airplane, so you might want to check that out. It was a big Super Flying King with an 85cc DLE, same brand as this one. And it was exciting to me because I wanted to see how that engine, how hard it was to work with. A lot of these engines, like this one here that was a little bit rougher of an engine, it takes a while to break them in and stuff like that. A lot of these that are hand built just for the hobby tend to be a lot smoother on startup and a lot easier to run. So I was really happy to see how easy his was to run. I think we had to tweak the low end idle needle just a little bit to smoothen it out. We're at 4,150 feet here, which means that you have to kind of mess around with the jets inside of the carburetor to make sure that they run correctly for you, because we don't have as much oxygen here. And you know, that's probably why I'm a little bit goofy as well. So it's a joke. So anyways, that'll be it for this time. Next time around, I'm going to show you hinging, because I got all the surfaces hinged and we're just about ready to mount those up. And I'll talk to you about what's important about a hinge and why I picked what I picked. And so I'll see you next time.